known as solutions. So up to this point we've been graphing, but we haven't really talked about solving. And a big part of what we're going to do in the remainder of chapter 5 is solve quadratics. Because the solutions to a quadratic are typically what we care about when we talk about math problems. So we have in our warm-up, f of x equals x minus 3 squared minus 1. So this equation is in vertex form. So again, this is vertex form, which means that I can easily see my vertex. So it says, what is the coordinates of the vertex? Well, my vertex is h, which is 3, comma k, which is negative 1. So I have my vertex. That tells me where my graph is going to be at a max or a min. So in this case, my graph is going to have a min because the a value is positive, so that tells me it opens up. So I have the point 3, negative 1. My a value is 1, so what's really nice about an a value of 1 is that my y values are only going to be shifted based on the k. So my x's are shifted based on h. So instead of being at 0, 0, we're at 3, 4, 5, and 6. Because everything gets shifted right 3 units. And then the negative 1 takes all my normal points and shifts them down 1. So instead of being at 0, it's at negative 1. Instead of at 1, it's at 0. Instead of at 4, we're at 3. And instead of 9, we're at 8. Because those 0, 1, 4, 9 all get subtracted by 1. So I have 3, negative 1, 4, 0, 5, 3, and 6, 8. That gives the opposite point 2, 0, 1, 3, and 0, 8. So it asks you to identify the y-intercept. So I got the y-intercept through my graph. The y-intercept is at 0, 8. If you didn't get the y-intercept through the graph, you could find it algebraically, which I think is what some of us ended up doing on number 14, is you FOIL the x minus 3 squared, and then you kind of put it into standard form, and then to standard form to vertex form. So standard form to vertex form is more complicated. Vertex form to standard form is just FOILing and combining like terms. So if I wanted to take it from vertex to standard, I have to FOIL x minus 3 and I get x squared minus 6x plus 8. So this equation right here is the standard form of the vertex form. So AOS is simply the h value of the vertex. So my AOS is at 3. I have my y-intercept at 0, 8. My vertex at 3, negative 1. I made my table of values, and I got my graph. So that is pretty much everything we did last week in a nutshell. The only thing we're adding to it today is the solutions. So the solutions occur when a function equals what? Here. The solutions of a function or its roots occur when it equals 0. So in the case of this problem, the graph shows me my solutions. Because where does y equal 0? Well, y equals 0 across the x-axis. So the roots, or the solutions, are also known as what other special point we talked about sometimes in class? So in that, maybe it's never really been specified, but the roots and the x-intercepts are like the same thing. Okay, so you see one graphing and you kind of see one solving for y equals 0. So in this case, 2, 0 and 4, 0 are our roots. So anytime y is 0, that's our roots. Again, we're going to maybe do like formal definitions. We'll do it more, but like in the warm-up, you can see them. So, formal vocab, the solutions of a quadratic equation are known as their roots. The solutions of a quadratic equation are known as their roots. One way to find the roots of a quadratic is to find the zeros. The way you know most commonly how to do this is to factor it. The way you know most commonly how to do this is to factor it. One of the things I think we didn't talk about, and I just sort of added it in here, is that, okay, solving quadratics. When we talk about solving these equations, we want to find the value of x when y is 0. So you saw in the warm-up that the x value in y equals 0 is also known as the x-intercepts. You might hear me say the word solutions, zeros, or roots. All four of those pretty much mean the same thing in a different way. So the x-intercepts always occur and the zeros always occur when y is 0. The solutions or roots can occur when the equation is equal to something other than 0. So again, think about if you had an equation and it's set equal to 5. That would be still finding its solution. So you could have 5 equals x squared minus 9x plus 6. So you want to find the solution, but in this setup right now, the y value is 5. By subtracting the 5 over, you make the y value 0. So what we're going to do for all of our equations, if we're solving them, is we might have to manipulate them to be set equal to 0. It may not always be set equal to 0. There are 3 cases that can occur when solving a quadratic. A quadratic may not have solutions. A quadratic function may not have solutions. It might be shifted upwards and never cross the x-axis. A quadratic might only have one solution. So the parent function only has one solution. When there is one solution, this is what we call or refer to also as a repeated root. So remember, these solutions are called the roots. If the vertex is on the x-axis, then you have what we call a repeated root. And then we have the more common and most common, which is 2 solutions, because it crosses twice. Okay, so we have f of x equals x squared minus 4. So this graph is shifted down 4 units. So my vertex is at 0, negative 4. So if I were to solve this by graphing, then I would make my table of values, plot those points. So you would have negative 4, 0, negative 1, negative 3, and then that would give you 2, 0, and negative 2, 0. So this has how many solutions? 2. Where are they at? Negative 2, 0, and 2, 0. Similarly in this problem, again, if it's not in standard form, you could rearrange the terms to be in standard form. Look at your key points on your graph. Identify your roots as 0 and 2. So the roots are also the x-intercepts and squared crosses that x-axis. So if you don't have the graph, then that's why last week's lesson about graphing is so important. We're going to do all those same key pieces of information, but now we're going to identify one additional piece, which is the roots. So as I said, this week isn't bad, pretty much last week, but adding on, finding the roots or solutions. So y-intercept is the c-value, in this case, 0, 8. The axis of symmetry is my h value, or negative b, divided by 2a. The vertex comes from plugging in h. So negative 3 squared is 9. 9 plus 8 is 17. 17 minus 18, negative 1. So this graph is shifted left 3 and down 1. Technically, all of the points can go to the left or to the right. So you have negative 3, negative 4, negative 5, negative 6. Or that's the same as negative 2, negative 1, 0, and positive 1. At this time, our a value is 1, so all my y values are just shifted down 1. So instead of 0, it's negative 1. Instead of 1, it's 0. Instead of 4, it's 3. And instead of 9, it's 8. And then technically the next point is 16. You don't have to go that far in your table. That's why I just set an extra equal sign on mine. So those all act as your points. So negative 3, negative 1, negative 4, 0, negative 2, 0, 3 and 8. So again, the only thing new is what are my roots? And my roots are at x equals negative 2 and negative 4, because that's where it crosses the x-axis. Alright, so I will, I'm going to skip this one just because I want to show you the next one. I'm running low on time. So anytime you have a problem that does not have a y value, you want to get it so the 0 is on the left and the equation is on the right. So we want to get all of the x's on the right and the 0 on the left. So this will become 0 equals x squared minus 8x plus 16. So you always want to get it into standard form where you move the x squareds to the right and the y value or the 0 to the left. So that's a big mistake. Like sometimes they try to move everything to this side, but then that's all it's gonna do is like your graph might be open down and mine's open up, or mine's open up and it's open down. So if we follow the rule that you want all the x squareds always on the right, then that's on issue. Y-intercept is at 16. It is symmetric through positive 8 divided by 2 times 1, or 4. And then you take that 4 and plug it in. 4 squared is 16. 16 plus 16 is 32. 4 times 8 is 32, but it's negative. So what happens is my k value is 0. So this is also an example of where the vertex is also my root. So that means I only have one solution. I will only have one solution. We're going to have 4, 0, 5, 1, 6, 4, and 7, 9. Because the y values don't get changed because a is 1 and k is 0. So all that changed is my x values shifted right 4. Your homework is on the worksheet. Let me pass that out to you. It says day 2, but it's day 1, I promise. So that's kind of why I didn't put it in your packets, because I thought it might confuse you. So I'm sorry, because like in class day 2, it is our homework for today. I sort of changed things, but I like this worksheet.